Okay, so hello everyone. A very good afternoon to all of you guys, and welcome to Ashish Malik IS Academy YouTube channel. So I welcome you all to this live session, and today we are going to start our very brand new course, which is on physical geography. I'm sure you guys have been waiting for this course, and I'm very sure this is going to be very helpful for all the UPSC aspirant preparing for 2023 or 2024. Now, this is one such course which will be helpful for UPSC, for state PCS, or for any other government exam. If you are going to learn geography, then this is the best platform. I know geography is not an easy subject, and I totally understand geography is a kind of subject which will trouble you at some points because it's a technical subject. There are so many diagrams involved. There are so many phenomenons involved. So my try will be, or my honest try will be, to make this subject as easy as possible for all of you guys. So every day we are going to have at least 1 hour free class, and I'm going to cover this entire physical geography in around almost next 40 days. We are going to complete our physical geography with every day 60 to 90 minute session, and the medium will be English because English medium students were actually looking for this kind of platform. So first of all, make sure that guys you first of all make sure you subscribe to this YouTube channel and do like the video so that you are never going to miss any of the update, and every time I come online you guys get the notification. So before I begin, before I start my course, first of all guys, do join me on Telegram. These are my 3 Telegram accounts. I want you to join me over there so that you get the PDF of every session, you get everything that is required from my perspective. In future I will also provide you free test series, I'll provide you study material as well. So make sure that you guys are uh, going to get connected with me. So I hope you are already on my Telegram. In case you are not on Telegram group, then do join it guys. Before I begin, first let me break down what exactly physical geography is and what all we are going to cover. So let me give you a brief idea about the syllabus that we are going to cover under the physical geography. See, the entire geography that you guys have to prepare, you can break down the geography into many different parts. Well, there is one domain of the geography that is about the physical geography. In this physical geography course, what all domains we have, I'll discuss that also. Then there is another branch of geography where I will provide you a separate course on Indian geography. Then there is a third domain of what you call as human geography, and then there is something you may call it as world geography. So I have divided entire geography into 4 parts: physical, Indian, human, and world. And by the end, by January, probably by January, I will provide you courses on each of the geography one by one separately. Will start. So today we are going to start. This is the one which we are going to deal right now. So today we are going to begin with the physical geography course, and then later on these courses like Indian geography course we will begin somewhere in September. Then in somewhere November we'll start with the human geography, and probably in January I'll give you the world geography as well. So one by one, step by step, we'll cover all the geography. Today the physical geography course which we are going to start, exactly this entire physical geography can be divided into 5 domains. I always try to break it down into 5 parts. So physical geography, there are 5 major topics that we have to deal with. The very first thing that we have to deal in the physical geography, there is something called as very general topics, very general geography, very basic kind of things where we discuss about the basics, like we have the latitudes, we have the longitudes, all these kind of things. about the earth rotation, we have revolution, all these kind of basic points we have to discuss. There is another domain of geography where we will be discussing about the part of the universe, where we'll be discussing about all the stars, we'll discuss about all the planets, their related phenomena, all the latest missions that the world is conducting for the stars and the planets, the universe, how it formed, and every phenomena related. Then we have the three other major parts which we include as geomorphology, where it will cover all the landforms. We'll discuss about all the major landforms of the earth. We'll discuss about the two major forces in geomorphology, and those two forces are going to be endogenic and exogenic forces. Just try to understand. I'll explain everything, but first of all, you just need to understand what we are going to cover. Then we have another domain as climatology, where we'll be discussing about everything related to atmosphere and related aspects, entire atmosphere, its formation, structure, composition, atmospheric temperature, atmospheric pressure, cyclones, everything we'll be discussing. And the last domain we have is oceanography, which is basically related to the world oceans, and hydrosphere is what we are going to discuss. In this, we'll discuss all the physical features of the ocean. We'll try to understand the temperature, the salinity problems, the coral reefs, the biodiversity, and everything will be covered. So these are the 5 major parts that we are going to cover in physical geography. And in the end, we will add one more topic, and that will be biogeography also. In biogeography, biogeography is somewhere you will have a similar kind of concepts that will help you in environment also. So basically these are the 6 things that we are going to discuss. Very general, the universe, geomorphology, climatology, and all that. From where we are going to begin? Now this particular course that we are going to deal, this is where I'm going to start. This is my starting point. I will begin my syllabus. I will begin this course from the geomorphology part. We'll cover geomorphology, then we'll cover climatology, oceanography, biogeography, and this will also cover in between. This, for this you don't have any separate course. This I will keep covering in between. There will be one chapter included for all this. Universe part I will discuss last. In the end, we'll discuss the universe part. So don't worry, I have divided things with a I have very carefully divided the things, and you guys will not have any problem in that. Okay? So one by one we'll cover everything. I know many of you do not like geography, but guys, I have a promise. You attend my 5 live classes. You just give me 5 live classes, and I'm sure you will be in love with geography. For many of you, it might be a difficult subject, but trust me, I will explain the things with so much simplicity that you guys will never ever have any problem in geography. We'll discuss with a very basic. I'm not going to, I will start from scratch. I'll start the course with a scratch. For me, all of you are beginners. So I will start with a very beginner kind of level, and I will explain each and everything in the class. Now there are few rules that you guys have to follow. There are few rules that everyone has to follow. And the few rules include, number 1, you guys have to make class notes. I'm not going to read I'm not going to read the slides or something. I'm going to teach you in a very old style, and old style is a blackboard style. And I will explain you everything on this blackboard. So please, you make class notes, and on a daily basis, you try to revise them. Okay, class notes, and please try to revise them on daily basis. Rule number 2, make sure you never ever skip the class. Never skip the class, because then you will have problem in relating the topics. You will have problem in interconnecting the topics. So never ever skip the class. Make sure you come live. Make sure you come here every day. So the timing that we are going to follow is 12 p.m. In case you are not coming live, at least watch the recording, but do watch the recording. That will be helpful for you forever. Rule number 3, you have to participate in the class. I will ask you many questions and you should be, at least you should try to give the answers. Because one way geography can never be learned. Geography is a kind of subject which need interaction. So you and me, we have to interact. You guys have to participate in the class as much as you can. Rule number 4, along with this course, you guys also make sure that you read Geography NCERT. Make sure you read your Geography NCERT. Which one? You can start with class 11. I'm sure all of you having this book. This is the Fundamentals of Physical Geography. With this particular course, you have to read Physical Geography NCERT, which I'm sure you all will be having. Kindly read this along with this course. That is going to be very, very helpful because you learn the concepts from me and then you read them, which will be helpful for you forever. Last but not the least, rule number 5, you have to make 5 MCQs on daily basis. Whatever you learn, whatever you read with me, make 5 MCQs on daily basis and try to post these on your Telegram channels. Try to post it on your Telegram channels so that everyone else can solve it. Like making 5 MCQs daily will help you prepare geography for prelims also. And yes, I will give you lots of questions for mains. We will also do the mains answer writing along with this course. So you make sure that you write it on a sincere basis. You write your answers on a daily basis. Okay? So please do it. It's very, very important for you guys. I'm sure you will ask for resources also, what sources you have to follow. So guys, for your sources for physical geography, number 1 source, my favorite, NCERT. Nothing more than NCERT book. You just read NCERT book class 11th and that will be sufficient. Along with this, your class PDF is an add-on material. You kindly use it as an add-on material. My live classes will make it very easy for you, so trust on the live classes. And one last very important resource, very, very important resource that you guys have to use. Whatever we read, you can also use my book. There's a book called Geography NCERT Plus. This is a book. I have written this book. It's a question bank basically, helpful for prelims and mains. This is the book which I have prepared and I want you to read this book along with this course. There are so many questions in this book which you guys will find it very, very important. So make sure that you guys solve this along with this particular course. Okay, it's a Geography NCERT Plus book, will be helpful. It has questions, it has question for prelims, question for mains, NCERTs. It's basically a question bank. So do get your hand. This book is available on Amazon and Flipkart, and you will get special discount also if you buy it in this particular month. So these are the only sources. These are the only sources that you have to follow. If you have a lot of time, if you really want to, go for other sources, you can add GC Leong. There is no harm, but that is purely optional. Otherwise, all these are more than sufficient. More than sufficient. Clear? Chaliye, let us get started. So today is our day 1. Today is our day 1. This is the book I was talking about, guys. This is the book I was talking about. This is your Geography NCERT Plus book. And it has summary. It has 6 to 12 question. There's a complete, with every physical, Indian, human, places in news, maps, everything. It has everything. So do get your hands on this book. It's already one of the best-selling book, and I'm sure you will love it, guys. So today we are going to start with our chapter number 1. And what is our chapter number 1? It is domains of the earth. The word is domains of the earth. This is our first chapter that we are going to begin. So please make a heading in your class notes. Please put the heading as chapter number 1. And the very first chapter of physical geography. By the way, we are starting with geomorphology, okay? So don't get confused. So what major topic we are covering? So our major topic is geomorphology, and in geomorphology we are starting with our chapter number 1, and the chapter number 1 is about the major domains of the earth. Well, when I use the word major domains of the earth, see, major domains of the earth means in how many physiographic units I can divide my whole of the earth and its different components. And whenever we use the word major domains of the earth, we are going to discuss 4. How many total major domains we have? We have 4 major domains. And which are those 4 major domains, guys? The 4 major domains that we have include: number 1, our lithosphere. Number 2, we have our atmosphere. Number 3, we have hydrosphere. And the one in common for the 3 is biosphere. This is our lithosphere. This is our hydrosphere. And this is our atmosphere. Atmosphere has all air component. Then we have water being dealt with hydrosphere. And then we have all the land under the lithosphere. And where you have all the 3 together, if you have land, water, air together, there you will have the biosphere. This is our biosphere. Biosphere is where you will have, where the life exists. The domain where the life exists, that is biosphere. And your entire geography syllabus is also based on the domains of the earth only, no? In geomorphology, we are discussing lithosphere. In our climatology, we will discuss atmosphere. Hydrology, we will in oceanography, we will discuss our hydrosphere, right? And biogeography is about biosphere, the living sphere. These are the 4 things that we need to understand. But my very first basic question is, very basic question is, how we get all these domains, no? Very basic question that you need to know, that how the earth has got all its domains. In this chapter number 1, we have to find out this. This is our sole question. This is our major question. This is the main thing that we need to figure out in this chapter number 1. That how earth has got all its domains. How earth has got every domain. And that we need to understand, that how the things have happened inside the earth. Right, guys? First of all, tell me, do you think the earth was the same as it is today? How old is our earth? Do you know the age of the earth? Any idea about how old the earth is? Any idea about the age of the earth? Yes? Any idea how old our planet Earth is? Well, after many experiments, after lots of surveys and researches, especially the radioisotopic dating, using radioisotopic dating, we have got one basic thing clear. To the best of our knowledge, it is considered age of the earth is somewhere around 4.6 billion years old. Our earth is approximately 4.6 billion years old. This is how old the earth is. So obviously, the time when the earth was born, it was very different from the earth that we have today, right? Look at this journey of the earth. I'll share you something very beautiful here. Look at this journey. If you look at the evolution of the earth, because earth has actually evolved, and this evolution has happened in the last 4.6 billion years. In last 4.6 billion years. So from somewhere like this, Earth has now become this. It's a huge journey. And it is during the evolution of the Earth only. It was during this evolution only the Earth has got all the four major domains. So the journey of evolution of Earth is very, very same and very, very co-centric with the development of the four major domains of the Earth. Are you clear with that? So when Earth was formed, of course, the whole story began with the Big Bang, and we know all that fact also. So of course, the story begins with the universe, how universe was formed. So talking about the universe formation, we know that universe was formed somewhere around 13.75 billion years back, and the theory which explained it is Big Bang theory. It all started with the Big Bang, where a very one single atom, a singularity, one tiny ball kind of stuff which we call as singularity. It was basically a black hole which was having all the mass, super dense tiny ball, super dense singularity, having all the mass, having everything inside, to super dense atmosphere. And then it exploded some 13.75 years back. This one small tiny hole, black hole, exploded, and after its explosion, when it exploded, the whole universe was created. It is believed that after 3 minutes of the explosion, the first atom of the universe was formed. And from there onwards, around 6 billion years back, we have got the formation of our sun which is basically a star. Sun was born some 5.5 or 6 billion years back, and later around this sun we got all the planets. When we got our sun, around that sun, of course, we got all the planets. In those particular planets we have our Earth also. Earth is right now the third planet distance wise from the sun, and it is the only planet where the life can exist, because Earth is a part of Earth lies in the habitable zone. It lies in the habitable zone of the sun. Habitable zone is also called as Goldilocks zone of the sun. That means it is a perfect distance from the sun. It's a perfect distance from the sun where you can have water, where water can exist in liquid form. Because if you are too close to the sun, the water will basically evaporate. If you are too far away from the sun, then water will freeze. So this is the perfect distance from the sun where the water can be available in a liquid form, and that is the only reason why life exists on the Earth. When Earth was formed, some 4.6 billion years back, when Earth was formed, Earth was nothing but a ball of fire. Earth is not, don't expect Earth that we have today as same as that was 4.6 billion years back. It was not. When the Earth was formed, during its initial years, at the time of the formation, Earth was nothing but all covered with lava. Earth was nothing but a lava. You can call it as a ball of fire. Earth was nothing but a ball of fire. All the material of the Earth was in the form of molten material. It was all molten material, and on the Earth there was nothing but lots and lots of volcanic eruption happening. All the volcanic eruptions were happening. Earth was this much hot. That's why called as the ball of fire. Earth was made up of only the molten material. And now we need to understand, when Earth was, and this was a very volatile state. Let me tell you, this kind of Earth, which was only ball of fire and molten material, and it was very hot. It was very hot. This kind of Earth considered to be very volatile state. It is called the volatile state of the Earth, and this was its primordial state. It's a primary state of Earth. This was Earth's primary state, first at the time of its formation. But then something very miraculous happened, guys. What happened? What we saw, there was gradual increase in the density of the Earth's material. The Earth's material, which was nothing. What was this Earth material? Earth material was nothing but the molten lava. So that molten lava, molten magma, slight increase in the density happened, because obviously over a period of time the lava, it was cooling down, it was getting little dense, and when that happened, the outer part, this density increased in the outer part, in the outer layer of the Earth. So please try to visualize it very carefully. Now this is our Earth. So this outer part of the Earth, the material outside, now here the density got increased, okay? Here we have got the increased density. Now the outer layer of the Earth, the density of the material increased. Now you try to visualize where Earth has, it is all very hot, and only the outer layer become cold, or not exactly cold, the density increased basically. So all the heat which was inside, all the heat which was inside, it got kind of trapped, right? It got kind of trapped. It could not escape much, because the outer layer of the Earth, the material became dense, and due to more density, the heat was not in a position to leave the Earth. And that was a time, for the first time in the history of the Earth, for the first time what we saw, that internal temperature, Earth's internal temperature started increasing. Are you getting my point? Now Earth heat could not escape, that is why the internal temperature of the Earth starting increasing. Now that was a time when Earth was evolving. Outer layer density increased, heat could not escape. So heat, internal temperature of the Earth started increasing gradually, slowly, steadily, it was increasing. And guys, what do you think? What will happen if the temperature increases? Just think about it. That when Earth's internal temperature increased, it led to what? This increase in temperature, because of this, as a result, the material which was inside, the Earth, it started getting separated. Now very interesting, now understand this. Earth internal temperature increasing. All the material inside the Earth, it got started getting separated as per its density. I would like to give you one very common example. Just think about it. When you boil the milk, just take this example and you will never forget the concept. When you boil the milk, whenever you boil the milk, what you see, the milk is separated, and on the top of the milk, what you get the cream, right? The cream gets on the top. Cream is basically the fat, and below you have only the milk which is left. Am I correct? Whenever you boil the milk, you have milk separated from the cream. It's a common phenomena wherever there is increase in temperature, whenever you provide heat to something, After absorbing the heat, the material, they all try to settle down as per the density. Because the cream of the milk is having less density, that is why cream comes on the top. Milk, which is comparatively more dense, settled down below. The same thing happened. The same thing happened with the earth also. Due to increase in the temperature inside the earth, the material of the earth also started getting separated. Am I making sense to you? And how earth material was separating, guys? How earth material was separating? So all the heavy material, now you apply your brain, all the heavy material of the earth, what kind of heavy material? Like iron, like nickel, all the heavy material, all the heavy metal kind of stuff, this heavy material, it started sinking down. It started sinking down. It started sinking down. Where? It started sinking down towards the center. Started sinking down towards the center of the earth. And all the light material, the lighter material, what kind of lighter material, like you have silicon, like you have aluminium, all the lighter materials, they basically, they shifted towards the surface. They started shifted towards the surface. Make sense to you? Is it making sense? So due to increase in temperature inside the earth, the material start getting separating down. All the heavy material sink towards the center, all the light material started shifting towards the surface. Now, when this process was happening, with time, earth, of course, earth cooled down. With time, earth cooled down further. When earth further cooled down, and after earth cooled down, it also got solidified. Now earth was getting solidified. After it was cooling down, the things were getting solid. And condensation was also happening. Now when earth cooled down, it solidified. It also condensed. Earth basically condensed into comparatively smaller size. If you look, when earth was ball of fire, earth was having this much size. When earth was cooling down, it was getting consolidated, because everything which becomes solid due to more internal gravitational forces, earth was getting a perfect shape. And because of the inward forces, the size of the earth also got shrink. And this led to the present shape and size of the earth. Earth cooled down, it got solidified, and the size also became less. Now when the size becomes smaller, then it also helped in more increase in temperature, because the smaller the size, it will retain more heat. This is going to retain more heat, and this further led to separating of the material as per density. By the way, let me tell you something very interesting here, guys. It was during this cooling of the outer layer, at the same time, because the cooling of the outer layer, because the cooling happened from the outside, no? So first we got the cooling of the outer layer, and when outer layer got cooled down, it became solid. When it became solid, now this layer, this is how we got our first layer, which is the crust. Crust is the outermost layer of the earth, no? Crust is the outermost layer that we get. So, and now you might ask me, sir, why outer layer got first cooled down? This can be a basic question. And you must ask yourself, why outer cooling first? Then I'll give you one more example that you can remember. I'll give you one more example. And one more example is, think of it. Just think that you are eating khichdi. You eat khichdi you eat dalia, you eat porridge, anything. Whenever you eat any of these things, you know, when your mother has given you khichdi or dalia, the outer layer of the khichdi dalia, it cools down first, no? If you have ever noticed, if this is your khichdi dalia in your plate, you see the outer layer, because it gets in touch with the air, the outer layer becomes cooled down first. But if you put your hand inside khichdi, you will realize from inside it is still very hot, right? It is still very, very hot. If you put your finger inside, inside it is still very hot. You know, inside it is still very, very hot. But outside layer it cool first, because the layer which gets in touch with the air, there is a exchange of heat. So from the outer layer only we get some outer exchange of the heat, and that is the same thing happened with our earth also. So earth has become cool from the outside, and we got our first crust layer. But remember, internally the heat was still there. We still have the primordial heat. We still have the primordial heat, and this is the reason. That is the reason, guys. Even today, even today, when you go inside the earth, the temperature increases, right? When we go inside the earth, temperature increases. We know this phenomena. Temperature increase with increase in depth. So the more you are going inside, there is increase in temperature, increase in pressure, because there are two reasons. Always remember why the earth is still so hot from inside. आज भी हमारी धरती अंदर से इतनी गर्म क्यों है? One reason is because of the primordial heat which is still trapped inside. It is still trapped inside. And reason number two, it is because of the presence of radioactive elements. Because inside the earth we have some radioactive elements which continuously disintegrate, and they keep producing the heat. Radioactive materials are mostly present in the core of the earth. They are present in which layer? They are present in the core, especially the inner and the outer core. In the core of the earth we have radioactive elements which keep producing the heat continuously. So there are two reasons: primordial heat and the radioactive elements that we have, that the earth inside is still very, very hot. Make sense to you guys up to this point? Fine. Now one very simple question, if you can answer this question. Do you know the name of the process? Can you name the process where the material, when material separates as per its density, when the material separates, whenever the material separates as per its density, do you know the name of this process? What do we call this process, guys? What do we call this process? Any idea? This process is called as differentiation. Please note down. The process by which earth material was getting separated as per density due to increase in internal temperature. Now that process is called differentiation. Important for MCQ. You might get this question in your MCQ. The process with which the material gets separated as per density, the name is called differentiation. That process is called differentiation. But this process was still not complete. This was happening. The material was getting separated, guys. But you know, it was getting separated, but not completely. The material still could not get completely separated. Then something very interesting happened. You know, this process of getting layers, it got completed. around 4.44 billion years ago. Around 44 billion years ago, okay, I think the internet got slowed down. Is it fine now? I thought it got slowed down. And we are having a very heavy rains in Ludhiana. So we have just started our heavy rains here. I don't know if it is the same with you, but right now in Ludhiana we are having we are having a very heavy rainfall. It just started. Okay, so somewhere 4.44 billion years ago, this was a time when Earth got further heated up. 4.44 billion years back, Earth got further heated up once again. Do you know why? Do you know why? So Earth got heated up twice. In the geological history, Earth has the internal temperature of the Earth has increased twice basically. So one time was when the very first time the outer material density increased. And do you know why second time Earth got once again heated up internally? And if you know, the reason is very, very simple. It was during the moon formation. It was due to the formation of the moon. The moon formation led to increase in the heating of the earth. Now your question will be how it all happened, sir. Then I'll tell you one very simple reason for that. And please try to understand, because this is important process. Moon formation heating the earth actually led to the formation of mantle and the core, the two layers. The separation got complete. I'll tell you how. So basically what happened, guys, somewhere 4.44 billion years back, what happened? Some 4.44 billion years back. So we got our earth, okay? So this was the earth, and there was an asteroid. There was an asteroid, and the name of the asteroid was Theia. This Theia name asteroid was approximately 3 times the size of the Mars. Almost 3 times the size of the Mars. So this Theia asteroid actually collided with the earth. The Theia collided with the earth. And due to this violent collision of Theia and the earth, we got a depression on the earth. This Theia collided with the earth, and due to that collision, the Theia broken down completely, and some part of the earth also, we got a depression on the earth. And this violent collision of the asteroid with the earth led to heating of the earth. You understand? When two things collide violently, you can do that. You clap 10 times. You clap your hand 10 times, and you will see, there is some heat produced. So because of the physical collision of the two things, there is generation of the heat, and this violent collision led to heating of the earth. It increased the temperature inside the earth. Increased temperature inside the earth. So what happened when this collision happened now? It was then the debris, all the debris which were created, all the debris which were formed as a result of the collision. Guys, later on, these debris only, these debris, they basically consolidate. They basically consolidate and they take the shape of the moon. Are you getting the interesting point? Due to the collision, due to the collision of Theia and Earth, all the debris that were created, later on, they took the shape of the present day moon. And it is believed that all the depression that was created, now later on that became the Pacific Ocean. That somehow became the Pacific Ocean later on. You getting my point? This theory is presently, this is the most accepted theory, and this theory for the formation of the moon is known by the name the Big Splat Theory. This is called the Big Splat Theory, also called as giant hypothesis. It is also called as giant impact hypothesis. Okay, you can call it Big Splat also, you can call it as giant impact hypothesis also. So this was a time when earth temperature inside further increased, and then this, due to the increase in temperature, we got further differentiation. We got further differentiation of the material, and this, due to the differentiation, the earth forming material got separated, guys. After the big splat, you can write down, after the big splat, which led to further differentiation, because of this, the earth forming material actually got separated into three different layers. We got three different layers, and those three different layers that we have today is the crust, the mantle, and the core. With core having all the heavy material. This core is made up of all the heavy material like iron and like nickel, and that is why core is called Nephe layer. Whereas the crust and the mantle, they are made up of light materials, with the crust called as Sial. Sial means silicon aluminium, and mantle made up of Sima, silicon and magnesium. But the core is made up of all the heavy material. That makes sense. That actually makes sense that, oh, as we are going down with increase in depth, the material density also increases. Are you getting my point? This is how, now because of the big splat and differentiation, the earth has got all its three layers. So tell me if it is true or false. Now you have to tell me if it is true or false. If I say the density of Earth's material, the density of the Earth's material increases with increase in depth. Tell me if it is true or false. Tell me if it is true or false. The density of the earth material increase with increase in depth. Is it true? Is it false? Absolutely true. Yes. You can put it as a note also. Note down, important for MCQ. Along with density, please make sure, always remember. Now, some additional information for you. Now, with increase in depth, two more things which also included, there is also increase in temperature, and there is also increase in pressure. Okay, temperature also increases and pressure also increases. The two things also increase. Just have a look at that. Whatever we have explained so far, kindly have a look at that. Kindly, this is your big splat. Look at this. This is your big splat theory. You can see Earth, you can see Thea is coming, Thea striking down. This is the impact. And then we got the disk of the debris. And these debris, these small pieces, later solidified to create the moon. And this is the debris coalesces that we have. And this is how we got our moon. This is the big splat theory. You can call it a giant impact hypothesis also. This is exactly what I have explained to you guys. And this is how we got our structure. So right now, present day, if you look, we got our structure like this. We have got the three layers. I'm going to make it a little zoom. So look guys, this is the outer. This is where we live, right? This is basically where we live. So where do we live? Where the humans live? We live on the crust. We live on the first layer, the crust layer. That is something that we live. Then the second layer we have is mantle. The core itself divided into two parts. We have outer and inner. Don't worry, I'll explain. I will make you some diagrams for that also. Please make a diagram because we believe in class diagrams. I want you to draw it with me, guys. Kindly draw this diagram where we have to write down the layers of the earth. And let me tell you one very interesting thing. Whenever you have to prepare the topic of the layers of the earth, there are two ways we can do that. Layers of the earth can be classified by two ways. Layer of the earth, chemical layers of the earth. We can differentiate them chemically, and we can also differentiate them mechanically. The chemical layers of the earth means this is about the material they are made up of. Chemical layers is all about the composition of the layers. Which layer is made up of what? And mechanical layers means the physical state of the layer. Their physical state. Are they solid? They are liquid? They are semi-solid? This is mechanical differentiation. And chemical layer is all because what it is made up of. So I'll tell you on brief, I'll make you both diagrams and you have to draw it with me. The chemical layer of the earth is what we have as crust, mantle, and the core. Okay? Mechanical layers are lithosphere, asthenosphere, then we have mesosphere, then we have outer core, outer solid core, outer liquid core. We have the outer liquid core, and then we have last one as inner solid core. Please note it down. Please note this down. So there are three chemical layers and there are five mechanical layers of the earth. We'll make the diagram for both, okay? We'll make both the diagrams. And you have to draw these diagrams with me. So we have the two ways of classifying chemical layers, mechanical layers, okay? First, let's draw the diagram of the chemical layer of the earth. The first diagram that we have to make is the chemical layers of the earth. So how we have to draw this? Just you can draw it like that. Just this is the cross section of the earth. Let's say this is our cross section of the earth. We have the first layer. The first layer that we have is called the crust. Then we have the mantle. And we have the core. We have the crust, we have the mantle, and we have the core. The crust is basically from the top to the 35, average depth 35 kilometer. So first 35 kilometer we have the crust. Now mantle is basically from 35 to a depth of 2900 kilometer. From 35 to 2900 kilometer we have the mantle. And core is right from the 2900, it will go to the radius of the earth. From 2900 it will go all the way back to 6370 kilometer. This is the radius, by the way. If you do not know, please note it down. The 6370, this is the radius of the earth. This is the center point of the earth. That is our center point. Okay, this is the center point that we have. So crust, mantle, core, first 35 kilometer crust. The mantle is till 2900 and core is 2900 to 6370 kilometer. So I hope you remember the depth. You also have to remember their composition. So crust, like I told you, crust is called sema. The crust is also, it is called sial. The crust is what you call as sial. It is made up of silicon and aluminium. So it is what you call as sial. Mantle is what is made up of silica and magnesium. And that is why we call it as sema. And then we have the last one, the core, which is made up of iron and nickel. And that is why the layer is called Ni, nickel, Fe, iron. So please remember, these are the three chemical layers of the earth that we have. Crust, mantle and core. That's the chemical one. So basically now you can see chemical is composition. So the difference is of what they are made up of. So clearly this is the composition is different. So based on the composition we got the three chemical layers. But what if we have to draw the mechanical layers? I hope everyone has drawn this. I am going to erase it now. Please make sure that you have also drawn this along with me. Now I'm going to erase it and I'm going to draw the mechanical layers. So now we have got the mechanical layers. So which are the mechanical layer? Let's draw one more diagram for that. The mechanical layer. The mechanical layers of the earth. Let's draw this also, mechanical layer of the earth. The same diagram we have to draw once more. Remember, mechanical is going to be about the physical state. Mechanical layer, important is the physical state. What kind of state? If you are solid, you are semi-solid, you are liquid, that matters. The physical layer of the mechanical layer of the earth. The first mechanical layer is lithosphere, my dear friend. It is lithosphere. This is the first one called lithosphere. The second one called asthenosphere. The third one called mesosphere. Outer and inner. Please keep drawing with me. The first layer, this is called lithosphere. When I use the word lithosphere, it means up to 200 kilometer. The first 200 kilometer, it can be your lithosphere. So please remember, lithosphere is not same as crust. Many people make this mistake. Crust is not same as lithosphere. Both are different. Crust was only 35 kilometer. The lithosphere actually is the crust plus some part of upper mantle as well. No, it is crust plus some part of upper mantle also. So there is a difference. So many people, you also avoid making this mistake. So lithosphere is not same as crust. Lithosphere is much more thicker. It is way thicker than this, right? So what we were discussing. So first 200 kilometer we got the lithosphere. Then we got, and lithosphere is basically, okay, I'll discuss that later. The second layer is asthenosphere, which goes up to 650 kilometer, which may go up to 650 kilometer. This lithosphere, my dear friend, is absolutely solid. This is rigid solid. The first 200 kilometer of the earth is rigid solid. It is actually a very solid part of the earth. And you have heard of the tectonic plates, right? It is basically this lithosphere only. The lithosphere is only that we call as tectonic plate. You must have heard now that tectonic plates have moved. Due to movement of tectonic plates, we have earthquake, we have volcanoes. Yes, it is true. It is basically the movement of the lithosphere only which give rise to all earthquakes and volcanoes. So it is the rigid solid that moves. And we got lithospheric plates are only called as tectonic plates. So remember this fact, it is rigid solid. But it moves over a semi-solid, guys. Asthenosphere is semi-solid. It is not solid, it's a semi-solid. And asthenosphere, you can just for the sake of your example, remember it. I mean, just imagine lithosphere as biscuit. If lithosphere is a biscuit, okay, and it is moving over a jelly, so you can remember that. So asthenosphere is a jelly. Wherever the jelly moves, the biscuit on top is also going to move. Are you able to visualize that? So lithosphere is like a biscuit and asthenosphere is like a jelly. Wherever the jelly is moving, now why it moves, it's a separate question. For that we have to wait little longer. But it is actually the asthenosphere which moves. And whenever the asthenosphere moves, asthenosphere is a semi-solid. Asthenosphere is also called the storehouse of magma. Let me tell you. The word astheno means weak. The word astheno means weak. Asthenosphere, which is a weak sphere. Why it is called weak? Because it is the storehouse of magma. All the magma lies inside it. All the magma which comes during the volcanic eruption, the magma is basically all stored in asthenosphere. That is why it is a very weak store. It's a semi-solid. So asthenosphere, wherever the asthenosphere moves here and there, the lithosphere on the top is also going to move. Please remember it. So first layer lithosphere, first 200 kilometer. The second layer we got is asthenosphere, which is up to 650. Then we got the third layer. Third is called the meso. It is the mesosphere, which is again kind of solid. Mesosphere is, or you can also call it as lower mantle. So sometimes we can classify asthenosphere sometimes is called the upper mantle and meso sometimes is called the lower mantle. Okay, just I'm trying to compare. So mesosphere is the third mechanical layer and it will go up to depth of 2900 kilometer. Same as the depth of mantle. After that, after 2900 kilometer, even the core is different. Because we're talking about the physical state, then we got the outer core is liquid. Always use the word outer liquid core. And this outer liquid core, no need to mention, it is very obvious. It is totally liquid state, guys. It is absolutely in liquid state, not even semi-solid, it is purely liquid state. So outer core, and why it is like that? Why it is all liquid? Because of the extreme temperature. Because of the extreme temperature, all the iron, all the nickel is in liquid state due to extreme temperature. It is so hot in there. If you look at the temperature here can reach up to 4000 degrees Celsius. Imagine the temperature is somewhere 4000 degrees Celsius, and because of that much temperature, the material inside is totally molten. It melts down, the iron nickel melts down and becomes a liquid core. And this goes up to a depth of 4300. Up to 4300 kilometer we have the outer liquid core, and then we have the last layer, which is solid inner core. This is not liquid, it's a solid inner core that we have after 4300 till depth of 6370 kilometer. Now you and now you should ask me that, sir, at 4000 degrees Celsius we have got the liquid core. Do you know the inner core temperature is 4700 degrees Celsius? But that is the question, that then why it is also not liquid? Why it is also not liquid? Well, the explanation is simple. I know the temperature is huge, but guys, at this depth, we have extremely high pressure also. It is extremely high pressure that despite the melting, even the melted part, they become so much intact to each other, they look like solid. Please understand. In solid inner core, the material is liquid, but even the liquid is compressed so much due to extremely high pressure. Material is so much compressed that it is as good as solid. You getting my point? Temperature melts the material, but pressure makes it compress so much it is as good as solid. So these are the 5 mechanical layers of the earth: litho, astheno, meso, outer liquid core, inner liquid core. Now you know both. Now you have a good understanding of chemical layers and you have good understanding of mechanical layers. I'm going to erase it, so please make sure you draw it completely, and please have a look at that. Just for the sake of reference, I have also added this picture, guys. So here you have the two layers. Now you see, due to stress, what we got all the mechanical layers. This is the mechanical layer part. We got litho, we get astheno, meso, outer and inner. You see, and based on composition, we get all the chemical layers. So in your PDF, you will have all of this. In your PDF, you will have everything inside. Okay. Now don't get confused. Here they have written that the crust is also of 2 types. The crust itself can be of 2 types. The crust that we have, crust can be 2 types. It can be continental crust. It can be oceanic crust. The continental crust is made up of granite, and the oceanic crust is made up of basalt. In your chapter 2, when we will discuss the internal structure of the earth, we will discuss everything in detail. It is just an overview. In our chapter number 2, we have a chapter called structure of the earth. There we will discuss everything in complete detail, so you do not have to worry about it. So are you okay with that? Have you understood the mechanical layer? Have you understood the chemical layer? If yes, then please give me a thumbs up. And if you have not yet liked the video, then what are you waiting for? Kindly like the video right now and give me a thumbs up as well, guys. Give me a thumbs up as well. And then we have to write a few points about lithosphere. It's important. Let's make some notes, very important basic notes that we have to make on lithosphere as well, guys. Please make a few notes on lithosphere. Put the heading as lithosphere. What is lithosphere? It is the rigid outer part of the earth where the thickness may vary between 10 to 200 kilometer. It can be 10, it could be 200 meter as well. Generally, we take the average as 100. So in some books, you might find this. In some books, it is written the depth of lithosphere is 100. So please do not get confused. 100 is the average. In reality, it can go from 10 to 200. As per NCERT, this is as per NCERT. NCERT has given it 10 to 200. Average is 100. So lithosphere is the outer rigid part of the earth, thickness with 10 to 200 kilometer. Please remember, whenever we use the word lithosphere, it means the whole of the crust plus some part of the upper mantle. Some part of the upper mantle as well. So please remember it very, very carefully. Is it one continuous belt? No. Lithosphere is not like one continuous belt. It is not. Understood? Lithosphere is not continuous. It is not continuous. Not continuous means instead of being one complete layer, it is not one complete layer. It is actually broken. It is actually broken. It is actually broken. And it is broken into many parts. And these broken parts of lithosphere is what we call, this is what we call as tectonic plates. Please remember, the whole of the lithosphere is broken into many, many parts. And these broken parts, you can also call them lithospheric plate. There is no harm. It is same. You can also call them as lithospheric plate. But most common word is tectonic plate. You call them lithospheric plate, call them tectonic, same part. But more common is tectonic plate. Remember, so whole lithosphere is broken into different parts. And lithosphere is not stable also. These broken parts, they keep moving. You can please add on this information. The broken parts of lithosphere, which we have just understood as the broken part of lithosphere, they are the tectonic plates. These tectonic plates, the broken part of lithosphere tectonic plates, they are not stable. They keep moving. They keep moving continuously. Continuously they keep moving. They are ever in motion. They are always in motion. And how do they move? I'm saying that they are always in motion. How they move? How they move? The answer is simple. They move over. It is because of the movement of asthenosphere. They move due to the movement of asthenosphere, which is lying below. So you can remember, you can recall that example I gave you guys. You remember that example, right? We have the jelly, and on that jelly we have this one big solid biscuit. There is a biscuit on the top. So wherever this jelly will move left, right, the biscuit will also move. So it is basically this asthenosphere moving this side, the above lithosphere will also move this side. So it is the movement of the asthenosphere that decides the movement of tectonic plates, remember. And this movement of tectonic plate actually cause large scale changes on Earth's geological structure. Also remember this. It's the movement of these lithospheric plates, actually causes large scale geological changes. Movement of these lithospheric plates cause large scale geological changes on Earth. Everything which is happening, be it continent formation, you see, maybe it is the formation of the mountain. The mountain building happens because of this. Even the continent, they build up due to this. Continent building is all because of this. You have got the earthquakes, it is also because of the tectonic movement. We have got all the volcanic eruption, that is also happening. So lots and lots of geological changes happens due to the movement of these lithospheric plates. Of course, this we will discuss in detail. Everything we will discuss in detail later on when I will discuss about the endogenic forces. Under the topic of endogenic forces, we'll discuss everything in detail. But I hope you have understood what we are trying to say, right? And please have a look at this. I want you to have a look at the tectonic plates. Kindly look at the tectonic plates, guys. Look at this. Well, this is the old diagram. This is the old diagram. So we basically have all the tectonic plates you see. In total, there are 7 major tectonic plates. And now there are 14 minor plates. There were 12. We have got 2 newly added. We'll talk about that also. 7 major and 14 minor plates. Look at the North America plate. This, if you can see this particular boundary, you know, this is one complete tectonic plate. It covers the whole of North America. So don't confuse the continent with tectonic plate. Continent is one of the part on that plate. You know, continent is one of the part. A plate has ocean also, a plate has a continent also. This is one major plate called North American plate. You see, there are total 14, there are 7 major plates. So we have the North American plate, it's a continental plate. Why we call it continental? It has more of the land area. Because it has more of the land area, that is why it is called continental plate. Similarly, we have South American plate, Antarctic plate, African plate, Eurasian plate, Australian plate, and then one we have is called the Pacific plate. So please remember, out of the 7 major plates, there are 6 continental plate and 1 purely oceanic plate. And you have to remember, the oceanic plate is the one which is made up of basalt, and continental plates are basically made up of granite. Remember it, please. So 7 major plates are there. These are all tectonic plates. These are all lithospheric plates. Now you can see, this is how lithosphere is broken into parts. It is not continuous like I told you. It is broken into different parts. And then there are so many minor plates that we have. Minor plates include Juan de Fuca plate, Cocos plate, you know, Caribbean, Nazca. There is one more called Scotia here, Arabian, Indian. There are many Philippine plates. But now the talk very recently, as per very recent findings, the scientists, they have added 2 more plates, guys. The scientists, they have added 2 more plates which we need to discuss. And look at these 2 plates. Please look at this. One is between Indian plate and Australian plate. Can you see that? Between Indian and Australian we have got. This is the 13th one. And then we have got one more here called differentiated as number 14. So now this may be a question. This is the latest map of tectonic plates. Do remember, this is the latest map of tectonic plates. Look at all the minor ones. Juan de Fuca, Caribbean, Cocos, we have Nazca, we have Scotia, right? We have Somalia, Arabian, Indian, Philippine, all are minor plates. But most likely the question will come on the latest 2 discoveries. And which are these latest 2 discoveries, guys? The 2 latest discoveries that we have to focus on that actually. So please, let's understand about the 2 new plates. So the 2 new plates that we have got, one is called Macquarie microplate. Macquarie microplate is the one which was near Australia. And then we have Capricorn microplate which separate Indian and Australian. Let's name them. Let's name these two. Now this plate number 13 that we have marked, number 13, this number 13 is called Capricorn plate. Capricorn plate. And this is Macquarie plate, number 14. Please remember, Macquarie is south of Australia and Capricorn plate is the one separating Indian and Australian plate. And I'm very sure you are definitely in your UPSC exam, in your UPSC 2023, I am very sure you will have question on tectonic plates because it's a latest discovery and you are likely to have question on that. So please make sure that you remember this particular topic. It's a latest discovery, so that is why we are discussing it with you. I hope everything is clear up to this point. I hope we have got the understanding of lithosphere as well. Any doubt you can ask. If not, then we are done. And look at the way, look at the movement. This diagram is about the movement of tectonic plate. Can you see that? Every tectonic plate is moving in a particular direction. North American plate moving northwest side. South American plate moving southwest side. African plate is moving, some part moving northward, some part moving eastward. And there is a prediction that in future, even Africa will break from here. This part will have a separate, this part will become separate, and that is where we have the Great Rift Valley also. We have the Great Rift Valley also. This is exactly from where African plate will divide, because some part of African plate moving other direction, some part is moving other direction. And already because of the Great Rift Valley, we have got many lakes being created. Very recently, lot of lakes being created. Lake Tanganyika, Lake Nyasa, all these lakes are being created due to a Great African Rift Valley. Okay, and they're always in motion. Now that motion depends. It's not that they are not moving at the same pace. Of course, the motion is different. Like there are some plates which are moving as slow as 2 millimeter per year, which is hardly noticeable. But there are some plates which move really fast, like up to 15 centimeter per year. So the rate of movement of the plates is, of course, it is different. Now details of that we will discuss in the plate tectonic theory. When I will discuss about the plate tectonic theory, there is a plate tectonic theory, very important. There we will learn about different type of the plates. Because of the movement of the plate, we have three types of plate. We have convergent plate boundaries, we have divergent plate boundaries, and we also have the transform plate boundaries. That we will discuss probably in our chapter number 5 or 6 that we will discuss later. So I really hope guys you are absolutely clear with whatever we have discussed today. That is the end of our session 1. This chapter 1 is still going on. The remaining we will discuss tomorrow. So this was our first session. Tomorrow, the same time, 12 p.m. we will, like today we have discussed the evolution of the lithosphere we have done. Tomorrow the discussion will be on the evolution of atmosphere, hydrosphere and biosphere. So today what we have learned so far, today I told you, now let's quickly revise, let's quickly see, let's have a quick revision what all we have done today. So today what we learned, we understood, we have covered the topic of the age of the earth. We have learned about the age of the earth. Then we learned about the evolution of the earth. And during the earth evolution, we understood the process of differentiation. We understood the process of differentiation which led to the formation of layered structure, which led to the formation of earth layered structure. We also learned about the big splat. We learned about the formation of the moon in between. And in the end, we have also learned about the basics of lithosphere. Okay, the first domain that we have covered. Remaining we'll discuss tomorrow. So make sure, guys, that you come tomorrow, and tomorrow we'll discuss about the what you say, the atmosphere, its evolution, everything we will discuss completely. PDF, okay, PDF you will get. Don't worry. The PDF I will share on my Telegram channel. Like I told you guys, this is my Telegram channel. This is my Telegram group. So this is where you will get the PDF. So I want you to join the Ashish Malik IS Academy Telegram channel. Kindly join it, and there I will give you this. Just a minute, guys. Okay, again there was some internet issue. Anyway, so this is where you will get all the PDFs. Okay, so make sure you join the Telegram group, and there you will get every update. There you will get everything that you need. Question now, no question for today. Question I will give you tomorrow, because it was just a beginning, so we have not discussed much. So tomorrow we will discuss. And also don't forget to get the book that I have mentioned. Okay, try to purchase the book that I have mentioned for this course, Geography NCERT Plus. You have to solve MCQs for pre and mains. You have to follow this book. The link is also given in the description box. I have also given you the link on the top of your chat box. You can go and purchase this book, Geography NCERT Plus. It's a very good question bank that you guys have to follow. Okay, so do practice your questions from this. Okay, and like always, do not forget to come live at morning also. I hope everyone is aware. Every day morning 8 a.m. we also have a current affair analysis. I take that analysis on a personal basis. So do join me at 8 p.m. also. So now we have two classes. Okay, morning 8 a.m. and then 12 p.m. we have class for geography. So you have to cover for two of the sessions. Okay, I hope you have enjoyed, and these are the books you can add on in your UPSC preparation, guys. All these books are written by me, and you can add on to these books, and they will be very helpful in your preparation if you would like to see. So these are the 6 books. I have written books on Indian economy, geography. There is a 2000 question MCQs question bank subject wise, and these are the 3 books that you can refer for GS and current affairs. So I'm really hopeful that you will find these books useful. See you guys tomorrow same time. Take care. God bless you. Jai Hind, Jai Bharat.